All right, so I'm gonna do, I don't know, 1, 2, 3, 4, 5, 6, 7. I'm gonna do a bunch of problems for you guys, okay? And they're gonna take some effort, but hopefully you guys watched some of those videos that I posted up for you to watch. But this is the actual practice of it all, okay? All right, so let's start off with we'll start off with something that's can be handled, right? And then we'll go from there. So let's say that I give you a problem. I'm just going to call it number 1. I give you the integral of the 4th root of x to the 5th dx. So according to the rules that we have, right, this should be a problem that probably throws people off because of the way it looks, but it's actually a very basic problem, okay? The big thing here is to realize that we can rewrite this problem in exponential form. So if I were to write this in exponential form, what should it look like?
2 to 5/4.
Right, wonderful. So then I'm going to get x to the 5/4 dx. And now, because I have it in this form, I can use the power rule, correct? So the power rule tells us, just because I want to go over it with you guys, we add 1 and then we divide the power once we've added 1, right? But what else do we need with it when we have no upper or lower bound, when it's indefinite like this? We have to add a constant. Very good. So then in adding the constant, I should get x is to the 9/5, right? And then in the denominator, we're going to get 9/4, correct?
How do you get the 9/5? Because wouldn't like 1 plus 5/4 just be like 5/4 plus 4/4?
Oh, I'm sorry. That my bad. I don't know why I did that. That's funny. I reciprocated. It should be 9/4. Yeah. So then from there, this answer though ends up being 4/9 x to the 9/4 plus c, right? It's pretty straightforward.
Yeah.
Okay, cool. All right. Let's do this problem. Number 2. Now here, there's no rules that we have yet that will involve products, correct? And since we have a product here, we can't do this. So that means that, how did you want to... Oh, I haven't gotten to that yet. I'll talk about U-sub in a bit. Okay, so I'm just choosing a different variable. That's all this is. Okay, so to expand this then, I'm going to get 2u squared plus 9u plus 4 du. Does everyone agree with that?
Yeah.
Okay, and then we have 3 integrals here, right? 2u squared, 9u, and 4, right? We could break it up to be those 3. Do I need to show that to you guys, or are you guys okay with that?
It makes sense, the 3 integrals, but I know sometimes we'll put something, like for the first one, so 2u squared, sometimes you take out the constant, so would we do 2 and then the integral of u squared?
Yeah, the constant's irrelevant, right? That's from the rules. You can move the constant in front.
Okay, so would we do that? Like, would that benefit us?
Well, I mean, probably for you guys. I mean, for me, I already know the integral in my head, right? So it's if it's going to be beneficial to you, follow that.
Okay.
Right? So like for me, I know that by the power rule, this is going to become u to the 3rd over 3, right? And so it's just going to be 2/3 u to the 3rd, right? But if you need to be able to write the power rule and do all the steps that I did over here, by all means, be disciplined and do that. So, okay, I'll show all the steps. So if I break it up into three integrals, I'm gonna get I'm gonna get the integral of 2u squared du plus the integral of 9u du plus the integral of 4 du. Agreed?
Yes.
So you guys can all see it. Agreed? So then I'm going to get 2 times, and now my integral is going to be u to the third over 3. Correct? Plus some constant 1. Okay? Plus 9u plus some constant. I'm going to give it a different subscript. Plus 4u plus some new constant. Correct? Do you all agree with that? And in fact, this one should have been like this too. Agreed? So I'm going to get 2u cubed over 3 plus 9u. This should be squared over 2. I didn't do the integral to it. And then plus 4u. But what are 3 constants added?
Just like another constant.
It's just another constant. Does that make sense?
Mm-hmm.
Any questions? I tried to write all the steps so that people could see it all.
I have a question.
Please.
Well, it's kind of related. What if the exponent in your integral is -1? Like, say, for example, t to the -1.
Okay, so cool. So if you do the power rule to that, you get 0 over t to the 0 over 0, correct?
Correct.
Okay, so here's how we have to think about that one. So I can talk about that one real quick. So if I have the integral of t to the -1 dt, correct?
Yeah.
Isn't that the same as the integral of 1 over t dt?
Yeah, like that.
Okay, so ready? Here's where knowing the antiderivative becomes such an important thing. 4.9. What function's derivative give me 1 over t?
Natural log.
Yep. So the answer to this is the antiderivative, the natural log plus c.
Nice.
So there's some that you've got to know by knowing the antiderivative. Does that make sense?
Yeah.
Yes?
Yeah.
All right, cool. It's a good question. Obviously, it's a problem that I like because it means you know your stuff, right? So it's something that you should know. And you see, it's funny that you asked that because the next example was going to hit on that. So check this out. You were one step ahead of me. So if I give you the integral of 1 plus the root of x plus x all over x dx, we need to be able to know how to break this up, right? And so the way that we break it up is we break it up into 3 integrals, right? So I'm going to get 3 integrals. So I'm going to get integral of 1 over x dx plus the integral of the root of x over x dx plus x over x dx, right? The integral of x over x dx. And look at that first one. It's the natural log, right? So I'm going to write all the steps just to be deliberate for you guys so you guys can see it. So before I do this one, I'm going to get 1 over x dx plus the integral of x to the 1/2 over x dx plus this one's just going to be dx, right? Because x over x is going to give me 1. Agreed?
Yes.
Okay. I want to do one more step just to be super deliberate. So this is going to become 1 over x to the 1/2 power, correct? But I'm going to write it as x to the negative 1/2 power just because I want it in the numerator, okay? Okay, so we know this one now. So it should be the absolute value. I should be disciplined. This one then is going to be x to the negative 1/2 plus 1 over negative 1/2 plus 1 plus some constant. And then this one's going to be x plus some other constant. Are we all okay with that?
Yes.
Okay, so then I'm going to get ln of absolute value of x plus this will become 2x to the 1/2 power plus x plus some constant c. Right? And if we want to write it pretty, we could change that x to the 1/2 to square root of x. Right? But there is this problem.
How do you get like just the 2 in the x squared? Because wouldn't it be, because 1 plus negative 1/2 would just be 1/2 x to like the 1/2 power over 1/2?
Cool. And what happens when you divide by a fraction, my friend?
Oh, multiply reciprocal. Got it.
It's cool, dude. Look, it happens. One of the smartest students I ever had, she, on tests, would use a calculator to multiply 2 times 3. And I would walk by and I'd look at her and I'd tease her a little bit, like, what are you doing? And she's like, I don't trust myself on a test. I'm like, that's cool, man. At least you know yourself. So, God bless her. Another one of my smartest students multiplied 2 times 12 and wrote down 42. And I'm like, okay, that's obviously some test jitters, right? Like, so whatever you need to do to understand it, by all means. And if you need reminders, dude, it's perfectly cool. Ask. You know, I hope I've been very consistent about that with you guys to let you know that there's no shame in asking, all right? Hell, I ask questions that some people think are silly all the time, but I'd rather know than continue to not know. So, all right, next one.
Wait, quick thing. Can you...
Oh, no, dude, never mind.
Sorry.
I'm just kidding, dude.
The question, yeah. Cool.
Right after I go off about you should be able to ask questions, be like, nah. No, it was me teasing. I was teasing. You got it?
Thank you.
You good?
Yeah, we're good.
All right, cool. I saw you take a snapshot of it. All right, let's get a little bit more crazy, okay? So now we're going to start playing some games, okay? Now, what I'm about to start showing you means you truly know your derivatives. And this is where this class goes like this, right? It's been not too bad, and then we kind of take this like we're taking off in a jet. So we have this problem. The integral of 2 plus tangent squared theta to d theta. I can do the integral of 2. That's easy, right? But what's the integral of tangent squared? We should all be going like, oh, I don't know. I don't know that one. It hasn't been taught to me. Right?
Oh, you'd have to plug in, right? Sine over cosine?
Nope, that's going to be difficult because you don't know how to do the integral of sine squared and cosine squared. You don't learn that till Calc 2. So 10 times secant, that's secant squared's derivative. So one of the things is we got to play some creative games with this. So what do we know integrals of? So I'm going to do this. I'm going to go 1 plus tan squared theta, d theta. You agree that I have not changed the problem. Okay? No change. But I know something about this. What do I know about that?
Secant squared.
Oh, nice. Okay. Do we know an antiderivative that gets a secant squared? Oh, dude. So this becomes theta plus c1 plus tangent theta plus c2, which is going to give us theta plus tangent theta plus c. Now we need to be creative about what we know. So, what's going to happen here with your homework, guys? I'm going to find out, or your homework is going to take you quite some time if you don't know your derivatives. Because now we're starting to manipulate to be able to understand our derivatives. Does that make sense? So if I was you, I would get a chart, a paper, with all your derivatives there as reference so that you can use them. All right? You guys are like, no, dude, 2020. Oh, good. That's cool. Good. But that's important. That's important. All right, let's do another example. Are there any questions on how I attack this problem? You got your picture, Ray? All right. Cool. All right, next one. Now remember, if we have a product, do we know how to deal with products? No. For integrals. We don't have anything, so that means we need to distribute, right? So I'm going to get secant squared of x dx plus secant x tangent x dx with the integral. Right? And I broke it up. Do we know what the integral of secant squared x is?
Yes.
Look to your left. Look to your left. Right there. Look to the left. It's right here.
Yeah, tangent. Oh, yeah.
So this one will be tangent of x, though, plus c1. And what derivative gives us secant x tangent x?
The secant x.
Do you see how it's backward thinking?
Mm-hmm.
Right? So to attack this one, I had to do the antiderivative. I had to think, okay, what's the derivative that gets me this? Well, that's secant. So my answer has to be secant plus some constant. So what's going to end up happening is I'm going to get, okay, the answer to this is tangent of x plus secant of x plus some new constant c. Now, one thing I do want to let you know, to not stress you out about this test on chapter 5, we'll do it not Monday, but the following Monday. I mean, not Tuesday, but the following Tuesday. Okay? So what I'll do on Tuesday, I'll do 6-1. Thursday, I'll do 6-2. And then next Thursday, I'll do 6-3. And our class is done. There's no more topics. So we'll start reviewing for the final.
Would we do like a review for the chapter 5, or would do like a mini? Like,
No, yeah. I'll do something with that. I'll do something with that on Tuesday or Thursday.
Okay.
To get you guys ready for the exam on 5.
So it would be November 17th.
I'd have to look at a calendar. Not this Tuesday coming up, which is the 10th. So the 7th. Is it the 17th?
I think so.
17th. Okay. Okay. How about I let you guys try one? Yes, the last practice test was only practice. I'm not grading that. That was just to prepare you for the test. Sure, I could do a quiz. Oh, like another practice test type thing? It's just a question. Someone asked if I could give you guys a quiz or something. Yeah, I can do that again. Although you guys did see my test and my practice test were very, very similar, right?
I could do another practice.
Yeah, but I'm not gonna give you the exact thing for the exam. Yeah. One time, because if I do it too many times, then you'll know exactly what to study. It's rewarding people who put in the time, right? Okay. Anyone? What should we do?
Distribute and then use the power rules.
Okay, so if we distribute, what am I going to get?
Just radical of x times x squared.
Okay, but what is that going to be as a power?
Oh, x to the 1/2 plus x to the square x squared, so it would be x to the 3/2. Oh. Okay.
5/2? Right? What's 1/2 plus 2?
Oh.
1/2 plus 4/2 is 5/2. And I'm not just picking on you, Daniel. There's other people. You should see some people's faces. They're like, what? 5? How do you get 5/2? It's like, for real? What? I'm sorry, say that again?
It gets me all the time.
Oh, of course, dude. Look, we take the simple for granted, and then we look up, and it's like, wait a second, I got the most complicated part right that I was all nervous about, and then I forgot what 1 plus 1 was. So I get it, but does everyone understand how this becomes 4/2? All right, just making sure. All right, plus, then this should be 3/3/2. Yes?
Yeah.
Plus 2x to the 1/2 dx. Ray, we good?
Yeah.
The way you say that, dude. That's funny. Okay, Now we integrate. So this should be x to the 7/2, right? So this will be 2/7 plus, ooh, I forgot the x, that's silly, x to the 5/2. So this will be 6/5 plus x to the 3/2, and this will be 4/3 plus my constant c. Do you agree?
Mm.
Do you guys agree, or do you want me to show steps?
I agree.
So you just got the 6/5 just because you just multiply the 3 times the 2/5 on
Correct.
the middle.
Correct.
Then yeah, I'm showing.
Yeah, eventually, like, I remember when I taught high school, my students were all very bright, right? Obviously, but it was funny. They'd ask me for a problem, and then I'd just write the answer on the board. And I'd be like, do you guys get it? And then they'd stay quiet and not ask anything. So then I'd go, all right, let me go to the next problem. And then I'd just write the answer, and I'd be like, do you get it? And they'd just look at me, and then I'd be like, okay, good, cool, next problem. Eventually, they got to the point that they realized I was going to show no work until they asked questions. Because they're used to always being like, I'm the smartest kid in class, I don't need to ask questions, I get it. But when I broke them of the habit, they all started asking questions. And what ended up happening is we started having powerful discussions about what the math was doing and why. And they excelled because they understood the math. No matter what the problem was, they knew what questions to ask themselves. Now, I don't have the luxury or the time to do that to you guys, to try to break habits. But it's cool that there's some of you in here that are willing to be like, oh, hell no, I need to know. So continue to ask. It's good. Do you want another one to try?
Yeah.
Okay. Actually, let me do one. I want to do a definite integral one where we use the fundamental theorem of calculus part 2 so you guys can see it. And we'll go from there. So here we go. The integral from 1 to 2 of 1 over x squared. Minus. I'll go minus 4 over x to the third dx. Okay, so when I go to attack a problem like this, the first thing that I'm going to do is I'm going to go to negative exponents. And the reason I go to negative exponents is because I want to be able to use the power rule, because it's the easiest rule for me to use, correct? So if I use the power rule, I'm going to get a negative 2 plus 1 over a negative 2 plus 1 minus, here's 4, x to the negative 3 plus 1 over a negative 3 plus 1. And then obviously it's evaluated from 1 to 2, correct? But I want to clean it up, so I'm going to get negative x to the negative 1 minus, it's going to become a plus, 8 x to the negative 2 evaluated from 1 to 2. Are we all in agreement?
You got the negative x to the negative 1 because the bottom, the denominator was just negative 1?
Correct.
Right?
Yeah. Yeah. Are we okay with where I'm at?
Yes.
All right, cool. I'll rewrite it so it's this way. And now I'll do the bounds. Okay? So remember, it's the top bound plugged in minus the lower bound plugged in, right? So I'm going to get a negative 1/2 plus 8 over 2 squared minus a negative 1 over 1 plus 8 over 1. Agreed?
Yes.
So I'm going to get a negative 1/2 plus 2 minus a negative 1 plus 8. How do I want to do this to make life so easy for you? Here, I'll keep it in fractions. 3 over 2 minus 7. Correct? And then I'll be uber deliberate for you guys, okay?
Okay. Not too bad.
Hold on. Did I do that all right?
That seemed too easy.
Let's see. I want to make sure. Oh, you know what? I'm silly. And you guys didn't catch my arithmetic. Ready?
Yeah.
What's this?
Negative 2.
So why didn't I just go 4 divided by negative 2? I made a mistake arithmetically, and no one pointed it out. I multiplied by 2 instead of dividing by 2.
Yeah.
So this should actually be a 2. See, even I make mistakes when I'm not paying attention. So that's going to change this denominator. So this denominator would be 2 squared, right? Still going to be 2 squared. Yep. This will be changed. That should be changed. So this is all going to get changed. So I made a mistake. My bad. And I'm grateful I saw it. Does everyone agree with me about my mistake? You guys see it? So what's this going to be? Doesn't that become 1/2? And this is a 2. So I'm going to get 0 minus 1. So my answer should be negative 1. I started thinking I had a fraction in the denominator instead of just a regular number. So I multiplied and reciprocated. We okay?
Yes.
So you guys see how even the simple can cause a mistake. So just be very, 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 very careful with these problems, please. Here, let me do another one. What number was that? 8. So let's go to 9. Okay, what's the integral of e to the x?
E to the x.
Cool, it's itself, it's e to the x. So I'm going to get 5 e to the x. What is the integral of sine?
Cosine.
What is it?
Minus cosine.
Minus cosine, very good. And now we can evaluate that from 0 to pi. Ray? I see concern. Tell me what's going on.
Yeah, I was just confused about the negative cosine, but I got it now.
Okay. Okay. So just remember, the derivative of sine of x, right? If I take the derivative of sine of x, that's going to give me cosine of x, right? Right? But if I take the derivative of cosine of x, what do I get?
Yes, negative cosine.
No, negative sine of x, right? So the derivative of cosine gives me negative sine. So if I just have sine to integrate to go back, what isn't with sine that needs to be on this side if I'm going to do the antiderivative to go backwards? I need the negative. Right? Because we've learned the derivative of cosine is negative sine. But if I'm doing the integral of sine to get back to cosine, I don't have the negative, so I've got to bring the negative to the other side.
Okay.
I'll try to explain it to you. Okay? So if I take the integral of this side and the integral of this side, right? The integral and the derivative cancel each other out, correct?
Yes.
Cool. So I get, I'll get cosine of x. Agreed?
Yes.
But that's equal to negative sine of x. What am I taking the integral of over here, though?
Sine.
Sine. So that means if I want the integral of sine of x, what has to go to the other side?
Negative.
Negative cosine of x.
Okay, I get it.
Right? And here I should have added a plus c since it's indefinite. Does that make sense? So that's how I generate my things, is by knowing the derivative and then working backwards. And then making it look like the integral that I'm looking for. Does that help?
Yeah, totally. Thank you.
Yeah. It's my job, right? My job is to make sure you get it. So,
Great one.
huh?
You're doing a great one. A great job.
I really hope so. I hope you guys know I am trying to work my ass off to make you guys understand this calculus. I hope that comes through. Because, shoot, it's my job for one, but another thing is it's my way of feeling like I'm doing something for damn society. Shit. Okay, sorry. I shouldn't. Okay. So cool, we're good with the integral, right? Okay. So now when I plug in, remember, it's the integral evaluated at the top value, pi, minus the integral evaluated at the bottom value, which is 0, right? The lower bound 0. So I'm going to get 5 e to the pi minus 3 cosine of pi minus 5 e to the 0 plus, not plus, should be minus, 3 cosine of 0. Agreed?
Mm-hmm.
This is the fundamental theorem of calculus, part 2. F of b minus f of a, right? The b minus a, and in fact, to have proper notation, these are lowercase values. Sorry, being a bit anal. Okay, so what is cosine of pi?
0.
Cosine of pi?
Negative 1?
It's -1, right?
Yeah.
You can use your calculator since it's in radian. Make sure your calculator is in radian, right? And the reason you know it's in radian is because we're talking about pi. Okay, minus e to the 0 is 1, right? Minus 3 times, what's cosine of 0?
1.
Perfect, it's 1. So I'm going to get 5e to the pi plus 3 minus 5 minus 3 is 2, correct? So my answer should be 5e to the pi plus 1. Is there any questions? I figure you guys will inundate me with questions from the homework next week, both on Tuesday and Thursday. I'll make a good chunk of time to be able to answer questions for you guys. I want you to be able to understand this, okay? Like I said, we only have 3 more sections to teach you. They're doozies, but this is so important for Calc 2. And if you guys, whoever you take for Calc 2, whether it's me or whomever, I can't stress how important Chapter 5 is. Okay? It'd be great to have you guys again, actually, just because I feel like I have somewhat of a relationship with you guys, where I'd be like, hey, what's up? As opposed to having a whole new batch of students where I have to kind of start over. So hopefully you consider taking me for Calc 2. It'd be nice. It's hard to build relationships over the internet. I wonder how many people are getting married through someone they've met on the internet during this whole chaos. Right? I'm sure there's some. All right. Let me give you guys one to try. Try that one. Nice. Cool. Still need some time? Ray's like, nah. Okay, Ray, I'm going to have you help me. Okay, here's why. Yeah,
Yeah.
it's cool. It's cool. It's cool. So let's struggle through this together, okay? Because I think it's beneficial for all of us. Okay, looking at this problem, what the heck is the first thing you're thinking? Honest to God, just you see this problem. What do you think?
Break it up.
Daniel, don't tell him.
That's the first thing. Yeah, breaking it up. Well, like factoring.
Yeah. So question for you, because this is important. How different is the problem if I had done this?
I just don't freaking like roots.
Oh, don't worry about the roots, but could you break up the second problem I did?
Yeah.
The answer is no.
Oh.
No, because the bottom, they're different.
Yeah, think of it like this. If I have 5 plus x over 4, I can write that as 5 over 4 plus x over 4, right? But if I have 4 over 5 plus x, we can't break that up. So this one can't be broken up. Okay, so that's just some analysis for you guys to know. It's important for you to know that. All right? All right, so we're going to break it up. Tell me how to break it up. Don't tell him, Daniel.
Root y over y minus 1.
Okay, that's cool. What can I do with the root y over y?
Y to the half over 1.
Okay.
Okay, I'm done for the day. 1 over 1 half. I don't.
That's right. So I'm going to go okay, now what?
I don't know. The fractions always throw me off.
No worries. What have I done when I've had things in the denominator? What have I said?
What do you mean? Wait, sorry.
So if I have something like this in the denominator, haven't I said, hey, why don't we move that up and just make it a negative exponent?
Yeah.
So there's the key. So I'm going to go 1 over 4, 1 to 4 of y to the negative 1 half minus 1. Right? And what can I do now that that's to the half power?
That it's to the half power.
Right? It's a negative 1 half power. So what rules do we have that we can integrate this with?
The square root? I don't know.
So there's a rule. It's called the power rule.
Oh.
It's cool. Don't worry. Once we get to where we have just the variable to the power, we can do the power rule. And so this would have been y to the negative 1 half plus 1 over a negative 1 half plus 1 minus y, correct? And then evaluated from 1 to 4. But this is something that we have to know. Okay? But look how far you took us. Like, so many people look at these problems and the first thing, our inclination is to just be like, I can't do it. But you can do it. It's just, take your time. Right? And then, obviously, once we got to the integration piece, you got a little bit stuck, but then that's just studying the power rule. So, it's not something that's it's not possible. right? You have the ability. So give yourself a chance and try to do the problems, because when you don't give yourself a chance, you're not stretching your mind. You got it. All right?
Thank you. Thank you for your inspiration.
Well, I think a lot of us do that to ourselves, where we're like, oh man, like, I'm not even going to try. And it's like, oh, if you try, you realize maybe I only got 75% of the thing. But then the next time, I'm going to get 80%. And then the next time, 85%. And eventually, you kill it. I mean, look at me, dude. I freaking was a terrible math student. And now I'm a math professor. It's because I didn't quit. So always push. Please. Not for me, for you. All right. I wasn't trying to put you on the spot, please. I hope you know that.
Oh, I mean, okay.
All right. So I'm going to get 2 y to the 1/2, right? I did do that right? It's a fraction of the denominator, so I multiply by the reciprocal. Last time I messed up. I didn't want to mess up this time. Minus y, and then we're going to go from 1 to 4. So I'm going to get 2 square root of 4 minus 4 minus 2 square root of 1 minus 1. Agreed? So that's going to be 2 times 2 minus 4 minus 2 minus 1. So I'm going to get 0 minus 1, which will give me a negative 1. Cool? All right. But this is it, right? This is it. All right, what number was that? That was 10. Let me do another. See, what I'm trying to do today is just give you guys some practice problems to look at to see how the process is to try and solve them. Okay? So let's try another one, a toughie. How about from 0 to pi over 3 of sine theta plus sine theta tangent squared theta over secant squared theta d theta. I love it. Again, it looks daunting to probably most of you in here, right? Like, it's like, what is going on? But let's look at this problem and think of it in terms of, okay, and it happens to me too. I look at this problem like, okay, damn, right? Then I think, yes, I will post this later, I promise. I'll even post up these notes so you guys can have the notes of it worked out. What is something I can do?
Pull out a sine theta.
Awesome. I don't know if this is going to take us anywhere, but you're telling me, let's do it. So I'm going to get 1 plus tangent squared theta over secant squared theta d theta. Haha, crazy.
That's wow.
It's amazing, right? We looked at the problem, it looks crazy, and then we see this and we're like, oh damn, doors have been opened. What's the door that's been opened?
Secant squared. That's wow.
What's that?
1 plus tangent theta comes secant squared and it cancels.
So I'm gonna get sine theta secant squared theta over secant squared theta d theta. Now, how many guys don't know that 1 plus tangent squared theta is secant squared theta? Okay, cool. Appreciate that. Let me show you something. I don't know it either. The only one that I know is sine squared theta plus cosine squared theta is equal to 1. It's the only one that I know. Okay? So I'm going to show you something. I need tangent squared, correct? And what's tangent? Tangent is what over what?
Sine cosine.
Sine over cosine. So what I'm going to do is I'm going to divide everything by cosine squared because I know that's going to give me tangent. So what's sine squared over cosine squared?
Tangent squared?
Okay, that's the one that I know. So that's going to give me tangent squared. What's cosine squared over cosine squared?
1.
And then what's 1 over cosine squared? Or what's 1 over cosine? One over cosine is secant and then squared theta. You should know that trig. Now look at that.
Oh, wait, that makes sense.
Isn't that secant squared? So then I can replace this with secant squared. And look how simple the problem ends up being. Can you tell me what is the integral of sine?
It's cosine.
It's going to be negative cosine theta, and we're going to evaluate from 0 to pi over 3, correct? So that's going to give me negative cosine of pi over 3 plus cosine of 0. Well, what is cosine of pi over 3? Cool. So I'm going to get a negative 1/2 plus cosine of 0. So my answer ends up being 1/2. How's all this practice going for you? Is it helpful?
Yeah, really helpful.
Yeah, help me out.
All right. Okay. Let me do some U-substitution problems now. That's funny. Someone wrote privately to me, low-key love trig functions now. That's hilarious. But everything comes from sine squared plus cosine squared equals 1. You can get anything you want from there. So it's amazing how much your trig gets reinforced in Calc 1 and then even more so in Calc 2. Okay, all right, here we go. Ready? We're about to do some lifting. All right, what number was that? 12. 12. So now we're doing 12. So let's say I have the integral of x squared root of x cubed plus 1 dx. Okay? Now, have I told you anything about products? Right? I haven't taught you guys how to integrate products, so this means we're in a predicament. Is there something here that if I took the derivative of it would get rid of one of the other things? So there's two things that are happening, right? I have the x squared and I have the x cubed plus 1 and then the root, right? So it's really three things. But the root I'm not going to play with. I'm not going to play with that right now. If I take the derivative of what's under the root, am I going to end up with something that gives me an x squared? Yeah. So I'm going to make my u be x cubed plus 1 so that when I take its derivative, right, I'm going to get 3x squared dx. Okay? I'm going to get rid of the 3 because there's no 3 on that side. So I'm going to get 1/3 du is equal to x squared dx. Okay? So what I'm telling you is that 1/3 du is the same as x squared dx. Okay? So what's going to happen here is I'm going to go 1/3 du. So that takes care of this and this, correct? The square root is still there. What is x cubed plus 1? What's it equal to?
3x cubed?
What is x cubed plus 1 equal to?
U.
It's equal to u.
Oh.
Does that make sense? Now look how easy this integral has become. Now this integral is simply 1/3 the integral of u to the 1/2 du. Can we do that integral? Very easily, right? What is that? It's going to be u to the
3/2 over 3/2.
okay.
Oh, and then you multiply, so it's
I'll write it out because you probably don't see the 2/9, right?
2/3.
Which is going to give me 2/9 u to the 3/2 plus c. But what's u equal to?
X cubed plus 1.
So my answer is going to be 2/9 x cubed plus 1 to the 3/2 plus c.
Professor, can you go over how you got rid of the x squared at the top?
Yes. So look at it here. This piece, this thing, is equal to 1/3 du, correct?
Correct.
Okay. So that's equal to this piece. So 1/3 du takes care of these parts.
Oh, I see.
Then I keep the root, right? I kept the root, but what's this equal to? It's equal to u.
Because 1/3 is a constant goes outside of you.
Correct.
Okay, I see. Alright.
Okay? So I use the internal function under the root to see if I could use that to eliminate the x squared. Ready for me to do another one?
Yes.
Okay. Okay. Integral of 1 minus 2x to the 9th dx. Now, we could do this problem the long way and go 1 minus 2x times 1 minus 2x times 1 minus 2x times 1 minus 2x times 1 minus 2x, this long thing, right? We could do that and expand it and then have an integral that had like God knows how many terms to it, right? We could use the binomial theorem to do the expansion. Thank God that there is another way. Are you ready? The internal function here is 1 minus 2x, correct? The 9 is an external function. So I'm going to say, all right, u is 1 minus 2x. If I take the derivative, I'm going to get du is equal to what?
Negative 2.
Negative 2 dx. Don't forget the dx.
Oh.
Now remember, I don't want constants on that side unless they're in the original function. So I'm going to get a negative 1/2 du is equal to dx. Are we okay with that?
Yeah.
So my integral is going to be a negative 1/2 because that's a constant. The dx is equal to the negative 1/2 du, correct?
Mm-hmm.
Okay. I'm going to leave the 9, the 9th power. What is the parentheses equal to? What's inside the parentheses? What's it equal to?
It's u, so it's equal to the 1 minus 2x.
So this is u, correct?
Yep.
So my integral, if I clean it up, is going to be a negative 1/2 integral of u to the 9th du. Yes?
Yes.
So, can we do that integral?
Mm-hmm.
What's it going to be?
D10.
Over 10, right? And then let's not forget our constant because it's indefinite. So don't I get 1 over 20, a negative 1 over 20, u to the 10th plus c? And so it's going to be 1 over 20, 1 minus 2x to the 10th plus c. That's way better than expanding 1 minus 2x to the 9th.
So, this, and then, like, we've talked about this before a little bit today, but we just know that it's indefinite because we're not given the bound.
We don't have an upper or lower bound, correct.
When it's definite, then we can use the fundamental theorem.
Part 2.
Part 2.
Yeah, because there's a part 1 too. Don't forget part 1. How are you guys feeling?
Actually, kind of good.
Oh.
The math, I remember my pre-calc professor, he was like, the math, like in calc sometimes isn't that bad, it's just like the processes and knowing like the basic like stuff, like knowing your algebra.
Oh yeah, basically in this class you learn your algebra, right? 5.1 and 5.2 were all about your algebra.
Yeah.
That homework was like, dang man, that's long. Why? Right? For those of you who've already done it, it's tedious and long. All right, let's do this one. What do you guys think?
Looks scary.
No, it's not too bad. What do you think I should do? It's clearly it's a U sub, but what should the U be?
1 plus cosine x.
So if we get 1 plus cosine x, what's the derivative?
Just sine x
Oh, cool. Sine x
plus c.
dx.
Oh, damn.
It's the derivative.
Yep.
So then that tells me that du is the sine x dx, correct? So I'm going to get the root of u du.
And so we get, because since du is sine of x dx, that's why, I don't know, this is the proper terminology, but it like cancels out, kind of, like how there's no more sine x.
It's subbed out. Yeah, it's subbed out.
Okay.
Yeah. So then from here, we can do this one now, right? We've seen this one like 12,000 times, and we're like, oh, Montiel, I've got this memorized, right? Isn't the answer going to be u to the 3/2, so this is 2/3 plus some constant c? And then all of a sudden we're like, oh yeah, Montiel, it's going to be 1 plus cosine of x to the 3/2 plus c. Boom, Christmas. Oh, we did make one mistake. What is the derivative of cosine?
What was it, negative?
Negative. So then we need a negative, and a negative, and a negative, and a negative. That's why it's important that we understand what we're doing. When we do u sub, we take the derivative. So we're thinking integral derivative, and you've got to be clear about your thought. Okay? All right, let's do some more. Are you guys tired?
I like it. We're on a roll.
Okay. 15. I'm trying to take you through the journey of the integration. Right? All right, so here we go.
What are we using this for?
What, huh?
What are we using this for? Are you gonna expand it for like graphs or something later on?
Oh, the U-sub integration? These are techniques of integration that will become very, very important as you go further in math. You'll use U-subs a lot. So it's just it's one of the simplest techniques for integration that you'll use. So it's very important. Like, look at this problem here. I don't know how to do this problem. I mean, I do, but I don't know how to do this problem without doing a U sub to it. Because it looks really complicated to me. So in this problem, the only function that I have is 5 minus 3x. So I'm going to make that my u. And I'm going to go 5 minus 3x. And then when I take the derivative, I'm going to get a negative 3 dx. So I'm going to get a negative 1/3 du is equal to dx. So when I go to integrate, I'm going to get a negative 1/3 out front. But then I'm going to get 1 over u du. Do I know how to integrate 1 over u? Gerardo? Isn't this one we talked about?
Yeah, that's right. That's why.
It comes into play, huh? It's funny. So I'm going to get a negative 1/3 ln of absolute value of u plus some constant c. So I'm going to get a negative 1/3 ln of 5 minus 3x plus c. And this is my answer. Now, I know that that one was going to be ln from the get-go, but it's because I've spent 15,000 years doing these problems, right? Me and the dinosaurs were working on this stuff together. And so, for you though, for you to be able to see that this is a ln, doing the u sub to make it 1 over u makes it all of a sudden something very obvious, right? So the u sub clarifies the problem for you, so it's something that's manageable.
Could you have multiplied solved it like that, like, would it really make it? Because that wouldn't make it a natural law. Like, could you even do that?
Watch. I'm going to show you what you're saying. I'll take you down that journey. So we would have gotten this, correct? Okay. So then if we made u the denominator, right? Or you don't want to do a u.
No, you can do a U. I was just wondering if you just kind of...
Sure. So if I did that, look what's going to happen. I'm going to get a negative 3x. I'm going to get a negative 3 dx. And so I'm going to get a negative 1/3 du is equal to dx. So, okay, let's change it just so you can see. And I'm going to get a negative 1/3. And then I'm going to get u over u squared du. Where did that take us?
Same place.
Yeah. Multiplying top and bottom by that would do nothing for us here.
Okay.
It's cool, but you end up in the same place, right? Negative 1/3, 1 over u.
Yeah, why make it like more work?
Yeah, you're a multiplication thing that didn't help us simplify it. There's times that we will want to manipulate, but yeah, not there. That's cool. All right, want to try another?
Mm-hmm.
Like I said, I had problems for you guys for days today. Again, this is the du. What do you guys think?
U for the 4 minus y cubed.
So what do I get?
Negative 3y squared. And then we would get negative
what'd you leave? What'd you leave out?
dx.
dy.
Frick.
Because we're in y's.
It's just the y.
Right? Because it's in terms of y, so it's dy.
Yeah.
Okay.
And then it's negative 1/3 du equals y squared dy, and then you can sub out the y squared in front, I think.
Cool. So the y squared and the dy can go away.
Cool.
So I'm going to get a negative 1/3. And then I'm going to get u to the 2/3 dy. Do you see how the problem becomes so much easier by doing a u to it?
Yeah, so much easier.
And then we see clear as day, I'm going to get u to the 5/3. So it's going to be 3/5. So it's going to be a negative 1/5 plus some constant c, right?
Oh, because the 3's cancel?
Correct.
Okay.
And so I'm going to get a negative 1/5. 4 minus u to the 3rd to the 5/3 plus some constant c. Merry Christmas. Just trying to simplify our life a little bit. Does anyone need me to show the step on how I got the u to the 5/3, or do you guys now get the power rule pretty well?
Good.
Right? Okay. Another one?
Mm-hmm.
Or do you guys need time to write this down?
Oh, yeah, good.
Alright. I'll go on the next one, I guess, since no one's saying anything. What do you guys think?
I don't think that we can substitute, but I'm not sure.
Yes, we can do substitution here. Which one do you want to sub for?
Probably the cosine cube.
Oh, very smart. It's the cosine cube that we want to do it for, not sine. Because if we did sine, here's what would happen. So I'll take you down 2 journeys, okay, with the same problem. So here I'm going to go, okay, u is cosine theta. So du is going to be a negative sine theta d theta, right? So my integral is going to be negative u to the cube d theta, or du. My apologies. Agree?
Mm-hmm.
Is there anyone that doesn't agree with what I got there or is confused with what I got there? Oh, okay. So then this is going to become u to the 4th, a negative 1/4 plus c. So I'm going to get a negative 1/4 cosine to the 4th power theta plus c. And that's my answer. Okay? Now, I'm going to do u the other way. So I'm going to say u is sine theta. So then du will be cosine theta d theta. Agreed?
Yes.
So watch this. We're going to have a little issue. We're going to have cosine squared theta cosine. Ooh, hold on. Let me just write it so you guys can see. Sine theta cosine theta d theta. So I know that this is du, correct? So I'm going to get the integral. That's going to be my du. Sine is going to be u. But I'm still going to have cosine squared theta, right? But I can change that, and I will. I'm going to change that to 1 minus sine squared theta. U d theta. Or, I'm sorry, u du. du. But we said u was sine, correct?
Mm-hmm.
So, okay. So I'm going to go 1 minus u squared u du. And can you see that this is a pain in the butt?
Yeah, then it just kind of takes you back, right?
Well, wait up, they're not the same answer.
Mm-hmm.
But they're both right. Which one would you rather do?
First one.
The first one.
Definitely.
In fact, I kind of did bad math. I shouldn't have done the u-sub until I converted. But I wanted to show you that, wait, I can't be in DUs. So this is bad. Like I shouldn't be in DUs and still have theta. But I wanted to show you, wait, there's a problem. So I converted, not till here was I right. Really what should have happened is I should have gone, before I converted, I should have gone here. 1 minus sine squared theta, sine theta, cosine theta, d theta. Then I should have gone from here to here. Do you guys see that? But I wanted you to see, oh crap, cosine squared theta. Well, I can write cosine squared theta in terms of sine so that I could have my u sub be there. But look, the answers aren't the same, but the answer will absolutely be the same. Isn't that crazy?
Yeah.
Do you want me to see if I can prove that it is negative 1/4 cosine to the 4th theta? Just for fun, we'll do some trig.
Yeah, just for
Okay, let's see if I can do it. We'll go sine squared theta squared. So that's going to be 1 minus cosine squared theta over 2 minus 1 minus cosine squared theta squared over 4. So that's going to be 1 minus cosine squared theta over 2 minus 1 minus 2 cosine squared theta plus cosine to the 4th theta over 4. Agreed? Yes?
yes.
So 1 over 2 minus cosine squared theta over 2 minus 1/4 plus 2 cosine squared theta over 4. Oops, this should be a minus. 1/4 cosine squared theta. Right? Isn't that what we should end up with? Oh, cool. Let's see what happens. Minus 1/2 cosine squared theta over 2. Ooh, I can clean that up. Oh, well, I'll just bear with me. 1/2 cosine squared theta minus 1/4 cosine to the 4th theta. And really there should be a plus c, right? Right, because I just dropped the plus c. So remember that, there's a plus c. So don't I end up with 1/4 minus 1/4 cosine to the 4th theta? Right? Plus some constant c if I want, right? Because we had a plus c the whole time. But isn't 1/4 a constant? So I can write that as 1/4 cosine to the 4th theta plus some constant c. Right? Because 1/4 plus a constant is a new constant. Yep, I did it right. Isn't that cool?
Yeah.
I can prove my work. The answers look totally different, but they are the same. So, you tell me, you want to do the one on the left? 1, 2, 3 steps? Or you want to do the one on the right?
Right.
Always use the one that has the exponent. Okay? And if they both have exponents, then we want to convert to 1. Okay? And there's tricks and you'll learn those in Calc 2. But I wanted to show you, people always say, oh, you always get the same answer. Well, oh dang. It is the same answer, just doesn't look the same. Okay? You guys are like, what are you doing to us, Professor?
What do you mean when you combine them into one? Like if you had like cosine squared and sine cubed, like just like.
So, well, you'll learn that in Calc 2, but what I mean is, do you see how here I had cosine square cubed and then sine?
Mm-hmm.
When I went to do this, I had to convert that to sine when I decided to use sine as my u. So I manipulated it so everything that I was going to end up with was in terms of sines.
Oh, okay.
Now, when you get to Calc 2, they have rules for when one's got an even power, one's got an odd power, but we're not teaching you that in this class, so don't trip on that. Okay? I have a bunch more problems. I'll do. How about I do one more, and then I'll let you guys relax, and we'll do a couple on Tuesday.
Okay.
Does that sound good to you guys, or do you want me to keep going? It's up to you.
I think that sounds good.
What's that, Ronald?
I'll probably relax.
Okay. I just don't want to overwhelm you, but I wanted to give you a good chunk of examples of these problems so you guys could see them. And then I can do more on Tuesday, like I said. I don't mind. All right, let's do it. Let's do a fun one.
Professor Martel, when's our next exam?
Oh, I said that it was going to be on the 17th, right? 17th?
Yeah.
Yeah.
Number 7.
Oh, okay. I'm sorry, I didn't
Oh, no worries.
logged on late.
No, it's cool. No worries. Look, you're interested in knowing when something important in the class is going to happen, right? Cool. Ask the question. I'm not going to get mad at you. All right, number 17, right? I think 17. Oh, 18.
Yeah, we were on 7.
All right, I'm going to do another one to try and mess with you. Okay, this one, the u that I'm going to choose is the u that's inside of sine. So that root of x, see how it's sine root of x over root of x? I'm going to use this one as my u. And you'll see why in a second. So if I go u is equal to root of x, what's the derivative of root of x?
We have x.
1/2 what?
It's negative 1/2.
Let me write it this way. Maybe this will help you guys. Because now we're taking a derivative, right? So when we take the derivative, what's the derivative power rule tell us to do?
Multiply the 1/2 in front and then subtract the 1/2 minus 1.
Very nice. So I'm going to get 1/2 x to the negative 1/2, correct?
Mm-hmm.
So isn't, and then let's not forget dx. Isn't that, if I multiply by 2, because I don't want the 2 there, isn't that 1 over root of x dx? Right? Isn't x to the negative 1/2 power in the denominator root of x?
Yeah.
So look at this. I'm going to rewrite our problem. Isn't that the same thing?
Sure is.
Right?
Yeah.
So according to our u sub then, it should be sine of u du. Right? 2 du is dx over root of x, correct? Right?
Oh, yes. Yes.
So then what is the integral of sine?
Negative cosine?
Negative cosine of u, right? Plus some constant c. So I'm going to get negative 2 cosine. And I believe our u was root of x, right? So the innermost function that I used was the root of u. Okay? Now, want me to take you down a slippery slope?
Sure.
Ray's like, nah, man, this is enough. Okay, one of the things you could have done here to make life really kind of crazy is if I would have said that my u here, right? When I take the derivative, I end up here, right? But let's say you would have made this your u. understand that this u down here, it's actually a negative power. So it would have messed everything up. Okay? Because then you would have had you'd be doing a bunch of funky stuff. And should I do a funky problem for you guys so you guys can see it real quick?
Yes. Sure.
Should I do a funky problem? Let's see, do I have a sweet one? Okay, cool. Let me do one more funky one, sorry. And then I'll stop. It's fun to hang out with you guys. My interaction pretty much consists of a 16-year-old, a 14-year-old, and a 10-year-old. So,
Good demographic.
yeah, those are my kids. And my wife goes to work, so.
Pretty much all those ages at different times in the day.
Yeah, so I love them, but sometimes I gotta go away. All right, so check this out. Okay, this is the same as this, right?
Yes.
So the internal function here is arctan, right?
Right.
Okay, so I'm going to use arctan as my internal and see if it can do something to eliminate the x squared plus 1. So if I say u is tan inverse or arctan, what is the derivative of arctan?
1 over x squared plus 1.
Oh dang, look what it did for us.
Nice.
It makes this thing that looks so freaking ugly become u squared du. So, Carol, earlier you asked, why do we do U-subs? To make our problems become this. This becomes so pretty for us. We're like, this is like, oh God, I don't know what to do. And this is like, there is hope. And doesn't that just become u to the third over 3 plus some constant c? And so I'm going to get tan inverse of x to the third power over 3 plus c is my answer.
So you just got u squared just because, and we know that, like, well, not just because, but because you just set out inverse tan for u, and then since the u is 1 over x squared plus 1, then that gets subbed out, so then it just becomes like one function.
Yeah, so the reason I chose the arctan as my u was because I know that the derivative of it is x squared plus 1 in the denominator. So as soon as I saw that, I saw, oh dude, it's going to end up right here. Glorious. Right? Now eventually, when you get to Calc 2, you're going to pick problems where you're going to, instead of taking the derivative, you're going to take the integral. And that's going to be called a UV substitution or partial subs. It's fun stuff. And so you'll be thinking, you'll be having more techniques. You know? Fun. All right, can I do one more?
Not an even number. Sure.
Yeah. That's part of the, that's why, right? It's 2020, let's end on 20. All right. Sometimes the problem isn't conducive to just keeping it one function. So the denominator here now, what does the denominator look like? What could be the derivative that would get us that denominator? What is that denominator, right? It's 1 plus x squared, or from above, didn't that end up looking like the derivative of arctan?
Yeah, x squared plus 1.
Right? Now, if this is the derivative going this way, what's it this way? This is then the integral to go back, right?
Oh, yeah.
So if I have this and I take the integral of this, I end up with arctan, right? Okay. So going to our problem, the problem is it was 1 over 1 plus x squared that was arctan. So in this problem, I need to break it up. Since the numerator has multiple parts, I'm going to break it up. And so I'm going to get the integral of 1 over 1 plus x squared dx plus the integral of x over 1 plus x squared dx. Are we in agreement? Do we know this one?
Yeah.
We do, right? Isn't that going to be tan inverse of x? Right? Plus some constant. And then this other one, how can we do this other one?
Can you cancel out the x's and then do the same?
No, because it's 1 plus. So that doesn't work. It takes practice. It's a U sub 1 plus x squared. Look what happens. When I take the derivative, what do I get? 2x dx. So let's get rid of the 2. Do you see what just happened? This will become 1/2 the integral of what?
Then it's 1 over 1 plus x squared.
If we're going to do a du, what's it going to be?
Oh.
Okay, so, wow, this is big. So this part is this part, right? That's taken care of with the 1/2 and the du. This is equal to what? So then what should go here?
1 over u. Then so it's natural log of.
Oh, dang. All of a sudden we know what that integral is because we've seen it like 10 times today, correct? So sometimes it's going to be useful for us to break the thing up. This was, okay, we have this one memorized. It's in inverse tan, right? Because we know the derivative would give us this. So the antiderivative gives us tan inverse. This one here ended up being a
Natural log.
a U sub.
Oh. Yeah.
So we end up seeing that there's going to be times we're going to have to break things up, and some might be an antiderivative attack to it, while others will end up being a U sub attack to them. Okay, I feel like I did quite a few problems for you guys to try and help you. We can stop here, or I'll stop recording. Hold on.